Hi everyone, let's take a look at some questions where we have to describe the transformations of a parent function when given the equation of the transform function. So we have y equals f of x in this case, and we want to explain how these numbers that are transforming this equation will reflect in the graph of the function. So if you have y equals f of x, that is the parent function, then transformed to y equals this particular equation here. And these are the things that I want to actually point out before we start stating the transformations. So if y equals f of x is the parent function, then we're going to write every letter that appears in the parent function here in the same color. And I also want you to write a minus in the same color. So the reason why is because then we know, or we can see the rest of the numbers that are not colored in the same as the parent. They're coefficients that have changed, that have been brought in to the equation of this function. So like number 2, which would represent the coefficient a, like number 1, which is the number subtracted from x, and it represents the coefficient t, and the last number here, the number -8, that represents the coefficient c. So we're going to write them down. I like to list them vertically. And then we have d equal to +1. And then lastly, we have c equal to -8. An a of +2 means vertical expansion of 2 times taller, or by a factor of 2. Same thing. D of -1, +1, it means that there is a horizontal translation of 1 unit to the right. Now remember that when you see a negative in here, that means the value of d is a positive, so we subtracted a positive number, so that makes d positive. And c equals -8 means that we have a vertical translation in the negative direction 8 units, so that's 8 down. Next we have a quadratic function. Now in this case, the function given is a transform function, and we want to go to the basic or the parent function. So when you look at the basic function y equals x squared, you see that this has been transformed by this little number here, the -3. So what that means is, from an expanded function, we have to shrink it vertically to get to this, and then we have to reflect it. So we're going to say that if a equals -3 suggests that the parent has been vertically expanded and horizontally reflected. Horizontally reflected is reflection over the x-axis. It means that if we want to go back to the original function, then we have to go through a vertical compression. So if this is twice as big as the basic, that means you have to make it twice as small. So make it 2 times shorter, because we are trying again to get to y equals x squared. And the reflection over the x-axis means that we have to bring the function back to where it was by reflecting it over the x-axis. Now, how does this look like algebraically? So if you, for example, had the graph of a function y equals -3x squared, which means that the function has been flipped over here and stretched 3 times. So, and say, for example, this is y equals x squared, right? So in order to make this transform function into the basic, you first have to make this graph shortened 3 times, and then go back to reflecting it over the x-axis, and it will produce the exact same function, this one here. Now you have to think of the transformations the reverse way. Now this is a straightforward question, and what we have in this case is y equals x squared, so that's a parent, going to become transform function 2x minus 3 +3 squared, and then +4. So what that means is that we have a equals 2, we have d equal to +3, and we have c equal to 4. So that means vertical expansion 2 times taller. We have horizontal translation of 3 to the right. And we have a vertical translation of 4 up. The next question, we have y equals x squared, and we want to obtain the function y equals plus or minus square root of x. So let's try to treat this visually first. So if you have y equals x squared, and we're trying to get y equals square root of x, both positive and negative, it means that we're looking for something like this, right? So this is going to be plus minus square root of x. So one arm is going to be the root of x and the other negative root of x. Now, you are familiar with these type of graphs. Remember that we obtained the sideways parabola when we inversed y equals x squared. So we're going to say that the step that is missing in here, what we have to do here is reflect the function over the y equals x line, which means that inverse it. So inverse y equals x squared to create y equals plus or minus square root of x. So next question, we have y equals x squared minus 6. So again, I'm going to try to treat this first of all graphically. So if you have y equals x squared minus 6, it means that the graph of the function will have the vertex down at negative 6, and this will be the graph of the parabola. And what we want to do this time is bring this function from negative 6 all the way up to positive 2. Let's say this is positive 2. So if the function goes from negative 6 to positive 2, no other transformations apply. It means that we will have to move this parabola, this exact same parabola, so from negative 6 to 0, 6 units up, and then plus 2, 8 units up. So we're going to say that a vertical translation of 8 units up is needed. Now, next we have y equals x squared and y equals negative square root of x. So let's take a look at what we have first. So y equals x squared is our basic parabola here. And what we are trying to create is negative root of x, which is this graph. Now we know that to create negative root of x, we're going to need to inverse y equals x squared. But because we're only taking the negative, we're only going to need this arm of the parabola. So we're going to say that only this arm needs to be reflected, which means that step number 1, we have to inverse y equals x squared to create y equals plus or minus square root of x. Step number 2 is we have to limit the domain of y equals x squared. And we have to set the x values. Look at the x values for y equals x squared. They're all negative or 0. So step number 1 is inverse this equation. And then step number 2 is limit the domain to less than or equal to 0. And that's how we reach to the other equation. Now, if you have y equals x minus 5 squared, so let's take a look at this. So that means that we're going to have a parabola, horizontal translation of 5 units to the right. What we want to create is a horizontal translation of 3 to the right. So if you are at 5 here, we are trying to get at 3. So what that means is that we're going to have a parabola, the exact same parabola now, but moved horizontally. So to go from 3 to 5, we have to move horizontally 2 to the left. So therefore, we're going to say a horizontal translation of 2 to the left is needed. Now, next we have y equals x minus 1 squared plus 3. We want to get to square root of x. Now remember, to get to square root of x, we need to have y equals x squared and inverse it, and obviously restrict the domain. So what that means is that first we need to bring this equation to y equals x squared. So let's do this step by step. So this is going to have a few more steps, by the way. So we have x minus 1 squared plus 3. So what that means is that the graph of the function will have the vertex at 1 and 3. So, and there is our parabola, all right? And what we want to do now first is go from here to y equals x squared. So to go from here to y equals x squared, we have to reverse these translations. So 1 to the right means that we have to go horizontally translated 1 to the left to go back to the equation y equals x squared plus 3. And then vertical translation, so this is 3 higher than the parent function of y equals x squared, so we have to bring it 3 down. And when you bring it 3 down, that will change to y equals x squared. So once you have come to y equals x squared, now we want to inverse it. Okay, so we're going to go again. I'm going to color code them so that's easier for us to follow. So first we're going to go and bring the parabola 1 unit to the left. So that's what we create here. And then 3 units down, so that's what we create in here. And now we have the graph of the parabola y equals x squared. And once we have y equals x squared, now we inverse it. And inversing this will bring us to y equals plus or minus the square root of x. So it will bring us here. Now, because we're only looking for y equals positive square root of x, so we're looking only for this part, it means that we want to inverse only this arm of the parabola, which means that we need to restrict the domain of y equals x squared. So I'm going to say restrict the domain of y equals x squared to make it to any real number, but x has to be bigger than or equal to 0. And once you do the restriction, you have arrived to the graph of the desired parabola, which is y equals x squared right here, square root of x right here. So one of the arms of the y equals x squared. Now, next we have x plus 1 squared minus 4. We want to go to x minus 2 squared plus 1. Again, here we are. We have x plus 1 squared, 1 unit to the left, 4 units down. Here is the vertex. Here is the parabola that is given. So this is just a sketch, by the way. Okay. And now we have to change this to go to negative 2x minus 2 squared plus 1. So 2 to the right and 1 up. So the vertex that is 1 to the left has to go now 2 to the right. So what that means is that the vertex has to move 1, 2, 3 units in the positive horizontal direction, so 3 to the right. So when that happens, then we're going to have y equals x plus 1. So when you go 2 to the right, that means that you are subtracting 3 squared plus 1, which in simplified form is x minus 2 squared. Sorry, here we are still at minus 4, so minus 4. So that is where the graph of this function will be. So let's start with the first one. So the graph is going to go right down here. Okay, so that would be the graph of y equals x minus 2 squared minus 4. Now, we want to go 1 unit up, the vertex has to have the y value at 1, which means that if we want the vertex to go at 1, then from negative 4, now we have to go 5 units higher. which means that it's a vertical translation of 5 up. So what that means is that the function y equals x minus 2 squared minus 4, you need to add a 5 to the end of it, and that will create y equals x minus 2 squared plus 1, which is the desired parabola, and that's where it is right here. Now, next we have y equals 2x minus 1 squared, and we want to convert this to the square root of x plus 3 plus 7. So a couple of things first. You see that we are changing the groups of functions, so from quadratic to square root. We know from quadratic to square root we can go when we inverse functions. When you inverse them, we first need to bring them to the basic form, which means that we need y equals negative 2x minus 1 squared expressed in basic form. So that means that we have to take this function and vertically compress to make it 2 times shorter. So that will make this function y equals negative x minus 1 squared. So 2 times shorter means that you are dividing it by 2, okay? Now, you have to also reflect it over the x-axis. Let me change it a little bit. So reflect over x-axis means that you are changing the sign of it. So y equals negative x minus 1 squared will become now y equals positive x minus 1 squared. Now next we want to actually go from 1 to the right back to 0, which means that we have to go 1 unit horizontally, translated 1 unit to the right. So what that means is that we have y equals x minus 1 squared, and what we're going to do is going to the right, going from 1 to the right to 0, 1 to the left. It's going to add a 1. So, and that's how we'll create the equation y equals x squared. Now, once you have the equation in its basic form, you are going to inverse it. And when you inverse it, you're going to go from y equals x squared to y equals plus or minus root of x. Now remember, you only need the plus, so you have to restrict the domain. Restrict the domain of x squared. So if you have y equals x squared, and you want to get only this arm, that means that you only need this side of x squared where x is bigger than or equal to 0. So once you have brought the equation to y equals the positive root of x, so once you have inversed y equals x squared and restricted to 0, then you're going to set the transformations here. So as you can see, you have a horizontal translation of 3 to the left and a vertical translation of 7 up, and that would be the value of c equals 7. So once you restricted the domain to greater than or equal to 0, that means that your graph has now come to this point. So it's just the square root of x, and with a horizontal translation of 3 left, it will go to y equals the root of x minus negative 3 or plus 3, and a vertical translation of 7 up. 7 up is the drink, right? So x plus 3 and then plus 7 at the end, and voila, we have reached the destination. And this was a little bit of a longer video. I hope you found the instructions useful. And bye for now. Keep enjoying math, learning math. Bye for now.